Hello, this is from ToolChef. In this video I'm gonna show you how to create the navigation mesh and use it to drive the agent to a target position. So I prepared a simple scene here with some geometries here. And in this scene I want that my agent start from here and arrive here on this geometry here. Where is the locator there? So first things, let's set up the I field. So in this case will be composed by these two geometry. Let's create an I field, curve ground. Let's add the two shape selected. Okay, and then let's go my agent group, state machine, and yeah, set the ground there. Okay. So now I can create the navigation mesh. So let's select all the geometry in my scene, because it's the environment that I use to generate the navigation mesh. Go to the new nav mesh manager and add new nav mesh. Let's add a new name there. Let's add plus to add the geometry selection here and press OK. Create the locator, also compute already a nav mesh. So now we have this new locator that displays the navigation mesh, and here this one is generated by the geometry selected. So let's have a look to some parameter here. So here there are the nav mesh name that then you can use with the navigation module. If you want to specify bounding box instead to use the full bounding box of the geometry, just turn off this one and scale your locator or set some value here. And this one is the auto update. And in order that if you change something here, then it automatically updates the navigation mesh. Use styles is used to select the tiled nav mesh algorithm instead to use one single tile. In this case, the tile is faster because it uses multiple threads to compute the nav mesh. So let's have a look to some of the parameter. Let's turn off the auto update because we need to change some of the parameter here. So the tile size is basically to compute the nav mesh. This node can span the computation of a single tile on a core of the CPU. So in this case, the tile 500 I think is quite high, so you can reduce to speed up the computation. And the cell size to 1, so it's basically is the dimension of a cell used by the voxelization algorithm used by the nav mesh. And also the cell height, same thing, but for the height. So if you need more resolution, the height or on the x and z plane changes to value. This one tell how the height of the agent that used to compute this nav mesh. Then the agent radius. So in this way, the nav mesh algorithm know where an agent with this radius can pass through. And also you can see if you increase this radius, you'll see the distance between the walls here and the nav mesh here, it will increase. So if you want to increase this distance, just increase the radius. This one is the max climb, that is basically the max height step that an agent can do. So for example, if in this case I have like a step like this, that is and you want basically agent climbing on this geometry, you need to increase this value. In this way it generates a full mesh also here on the border instead to have a discontinuity here. The max slope is for ramp. In this case, for example, this one is 45 degrees. If you decrease this one to 10 degrees, then the nav mesh doesn't compute anymore the navigation, the polygon of the navigation mesh here, so the agent can't reach anymore this point. And here there are some other parameters used for set up the triangularization of the nav mesh, because if you check the wireframe, you'll see all the triangles that are generated by the nav mesh. And obviously, more detail you have here on the triangle, then the nav mesh has more definition when it computes the navigation path there. Okay, let's try this. Let's try out update. Let's switch to the wireframe so you see better the difference. So now you see, now this one is one tile is computed, and when you compute when the nav mesh compute the navigation path, it basically passes between every edge. So more edge you have, more you have detail on the path returned by the nav mesh. Okay, so our nav mesh is fine because it's continual the path here, also on the ramp here to reach this target. So let's add the navigation module. You can go for direction here. Navigation module, we need to set up the nav mesh that we created. Then we can set a target position. So we can use a explicit position here, or use a vector-free metadata containing a position. It can be set up from other behavior module. In this case, just take the component of this guy here. So it's this one, copy, and 150, oops, and 147. Let's increase the target radius. So the target radius is used to know if the agents are reached this target, and when it reaches this target, we can basically set metadata. In this case, we can make the agent stop, so we can control the state and set in value as 0. Last things that we need to do is basically go to the state machine and turn on the set state on agent chronologically, because if not, the state machine continue to set the state to 1, so we're not gonna work the navigation. Not gonna work the trigger metadata. Okay, so we can turn on debug. In this way, you can see the navigation path that is working fine because it's reaching there. So let's just press play and let's have a look. Cool, works fine. Here you have just a couple more data like the max turn angle. You can set up the maximum degrees that an agent can turn for one single frame. We can basically here turn off the computation of the path at every frame, but just the beginning. And then we can turn off the alignment of the agent at the first frame if you don't need to align the beginning the agents along the path. So basically that's it. Thank you for watching, and see you in the next video.